Lesson 823, problem 880. In this problem, we're given the quadratic equation y equals x plus 1 squared minus 16. In this problem, we're going to solve this two different ways. So the first way we're going to do it is putting this quadratic equation that's given to us in graphing form, we're going to put it into standard form and use the zero product property to find our x-intercepts, our roots. And then the second way, we are going to find the roots by evaluating the equation when y equals 0. Okay, so when we do this both ways, the vertex we can very easily see right away because it's given, the equation is given to us in graphing form. So I can use what I know about that to quickly write down what my vertex is. So remember, my y-coordinate of my vertex is going to be what I see at the end of my equation when it's given to me in graphing form. So I have a negative 16 there, so that's what the y-coordinate of my vertex is going to be. And then for the x-coordinate, it looks like it's the opposite of what we see inside the parentheses there, but really what we're doing is we're taking what's in the parentheses and setting that equal to 0 and solving for x. So if I took that x plus 1 and set it equal to 0 and solved for x, I would get x equals negative 1. So there we have our vertex. Okay, so now we have to find our x-intercepts. The first way we're going to do it in part A is getting this into standard form and then using the zero product property. So I'm going to rewrite this. So I have x plus 1 squared, which just means x plus 1 times x plus 1. And then I have that minus 16 there as well. So I'm going to go ahead and put this into my generic rectangle. And then solve for the inside. So I get an x squared here. X times 1 gives me an x here. Same thing here. And then 1 times 1 gives me a 1 in the top right-hand corner of my generic rectangle. So writing that out, I have an x squared. X plus x gives me 2 x's when I combine these. And then I have that 1. And then I have to remember to bring these minus 16s down as well. And then combining these like terms, I get y equals x squared plus 2x minus 15. Okay, now that I have this written in standard form, I'm going to go ahead and factor this using my generic rectangle and my diamond. So I have x squared, I have my 1's, and multiply those together to get the top of my diamond. My x's go in the bottom of my diamond, and now I'm looking for those factors that multiply to give me negative 15x squared and add up to give me 2x's. So those factors are 5x and negative 3x. And put those in my generic rectangle. It doesn't matter which spot they go in. And now I need to find the dimensions of my rectangle. So x times x gives me x squared. X times positive 5 gives me these 5x's. X times negative 3 gives me these negative 3x's. And then just to verify, negative 3 times 5 does give me those negative 15s. All right. So now I'm going to take those factors and set them equal to 0 using the zero product property and solve for x. So I'm going to solve for my x-intercepts. So each factor gets set equal to 0, and then we just solve for x. Okay, so I get that one of my roots is at negative 5, so negative 5, 0. And my other root, my other x-intercept is at 3. So at 3, 0. Okay, so now I have my two x-intercepts, and then if we go back up to the top, we solved for our vertex. So I'm going to go ahead and make a sketch of this parabola. So I'm just going to do a basic sketch here. Vertex was at -1, -16. So somewhere down here. Alright, and then I can just go ahead and connect those, just drawing my sketch. Alright, so we were able to make that parabola because we have our two x-intercepts and we have our vertex. Alright, and then now we're going to go through with the same problem, and we're going to see how we can find our x-intercepts another way. So remember, this was our problem. Y equals x plus 1 quantity squared minus 16. And then remember, we knew our vertex was at -1, -16. And now we're going to find our x-intercepts, but this time we are going to evaluate this equation for when y equals 0. So that just means I'm going to replace y with 0, and I'm going to solve for x that way. So this is just another way that we can get our x-intercepts. All right, so here we're at. So we've got to solve for x, so I need to get x alone. So the first thing I need to do is start undoing all the stuff that is happening to x. So I'm going to add 16 to both sides to start. So I get 16 equal to x plus 1 quantity squared. All right. Now I need to undo that square that's happening. So I'm going to take the square roots of both sides. Okay, so remember that square root undoes that square. So now we have x plus 1 on the right. And then the square root of 16. So I'm thinking that most of you are thinking 4, okay, because 4 squared would give us 16. But there's another number that when we square it, we get 16. And that number is -4. So 4 times 4 gives us 16, and -4 times -4 gives us 16. So when we take the square root of 16, we can get +4 or -4. So we write that as plus or minus 4. All right, then I'm going to keep solving. So I need my x alone, so I'm going to subtract 1 from both sides. So now on the left I have a -1 plus or minus 4 equal to x. And then I'm going to break that up so we can see the two things happening. So we have a -1 plus 4 equal to x, and we have a -1 minus 4 equal to x. So over here we get that x equals 3, and over here we get that x equals -5. And if you remember from above, those were the same x-intercepts we got when we solved by using the zero product property. All right,